All right, you guys. So section 7.2, similar polygons. We talked a little bit about ratio and proportion yesterday. Now we're going to take those concepts and apply them to polygons. So we use proportions to identify similar polygons. That's what we're going to do today. And solve problems using the properties of those similar polygons. So, some vocabulary here. Similar polygons are polygons that have the same shape, okay? Both triangles, both equilateral triangles, both squares, whatever, but not necessarily the same size. I mean, I could have an equilateral triangle that was this big and one that was very, very big. And so they have some of the same properties, but obviously some things aren't the same. What it boils down to is all of the corresponding angles end up being the same, but the corresponding sides are in proportion. So maybe this is twice as big as the other one, so everything's in the ratio of 2 to 1, okay? A scale factor is the ratio of the lengths of the corresponding sides, so that 2 to 1 that I was talking about there a second ago. So here's what similar polygons look like. So these two polygons, ABCD and WXYZ, are similar, okay? And this is the statement that we would use to compare them. Just like we did with congruent polygons, but now we just have this little tilde, which means similar. And it means that the corresponding angles are congruent. So angle A is congruent to W, B is congruent to X, etc. And you can see those statements there. And the corresponding sides are in proportion. So if I take the ratio of AB over WX, that should be the same as the ratio of BC over XY. And you can see that statement of proportionality over there. And in this case, that 15 over 5 is 3 to 1. That's the scale factor. Okay, so they're going to ask us to write corresponding congruent angles and a statement of proportionality and potentially the scale factor as we go. This is what this means. So this tells me that the two triangles are similar. Again, we can glean a lot of information just from that statement. I know that angle A is congruent to angle R, B is congruent to S, C is congruent to T, etc. They want us to list the pairs of congruent angles, which we just mentioned, and write a proportion that relates the corresponding sides. So AB over RS has to equal BC over ST, etc. And so that's what they're asking us for. And it's going to be written this way. So knowing that these are similar, okay, there's the corresponding congruent angles, so you need to list those. And this is the statement of proportionality. AB over RS equals BC over ST, etc. Okay, that's all we're looking for that example. Okay, so pause the video, give this one a shot yourself. So we know these triangles are similar. Determine which of the following similarity statements is not true. Okay, so angle HGK congruent to QPR. Those are exactly the same, so that's true. GH over PQ. GH corresponds to PQ, that's fine. GK then is over PR. Again, fine, they're in the same spots. Angle K congruent to angle R. They're both the third ones listed there. Angle H congruent to angle P. Ooh, those are not corresponding, so that would not be true. So if you got D for this, you did it right. Okay, so now Tan is designing a new menu for the restaurant where he works. Determine whether the size for the new menu is similar to the original. If so, write the similarity statement in the scale factor. Okay, in order for us to determine if they are similar, we have to look at that scale factor and see if it's the same for all of the corresponding parts. They're both rectangles, so we know the corresponding angles are congruent. They're all 90 degrees. But we need to check the sides. So the top for both of them, 10 over 12, would be that scale factor, and then the left side's 12 over 14. What we need to do is determine if that's the same ratio or not. Okay? So we compare the corresponding angles. We know that that's true. The corresponding sides, so there's that 12 over 10 is 6/5, 14 over 12 is 7/6. Those aren't the same. So although they look similar, they're not actually similar. The scale factors are not the same for the corresponding sides. So we have to conclude the menus are not similar. Okay? Okay, similar situations, similar menus. We're asked for the same question. We have different side lengths this time. So we're going to do the same comparison. Again, rectangles, the angles are the same. You know, is 10 over 8 the same as 12 over 9.6? We're going to test that, okay? So, or 10 over 8, 8 over 10, same thing. We get 4/5 here. If you simplify that, you also get 4/5. Ratios are the same, so now we can say those menus are similar. Same shape, but a different size. Okay? Pause the video, give this a shot. Okay, so very similar question, you guys. Are they similar, and if so, what's the scale factor? Okay, well, we need to check this. So they're both rectangular, so that corresponding angles are congruent. We need to check the sides. 8 over 16. Okay, you guys know that that's 1/2. 6 over 12. Well, that's also 1/2. So I would say, yeah, these are similar. The order that I put these matters, because again, BC and FG have to correspond, CD and GH have to correspond, so the order that I put those is important. And that scale factor is 1/2. 8 over 16 simplifies to 1/2. So if you guys got A, nice job. All right. Similar question, different size menu. Pause the video, give it a shot. Okay, so let's look at the corresponding sides again. So 8 over 12. Okay, I can simplify that a little bit. 4 goes into there twice, and 4 goes into 12 3 times. So that's 2/3. 6 over 8, comparing the left sides, divide each of these by 2. Those are not the same, you guys. So because the corresponding sides are not similar, we're going to say that the two shapes are not similar, okay? All right, the two polygons are similar, so they're giving me that information. They want me to find x. What I'm going to do now is use a proportion like I did yesterday. So I'm going to find some sides that are corresponding that I know the values of, so I can write the scale factor, and then compare that to x. So for instance, I would say that 6 over 4, those are corresponding sides, that would be the ratio of the sides, would have to equal x over 3. And then I just have a pretty simple proportion to solve, okay? 6 over 4 equals x over 3. We know 18 equals 4x. Divide by 4, x has got to be 9/2 or 4.5, okay? So setting up the proportion is the important part here, you guys, okay? Again, they're similar. This time find y. Well, 6 over 4 is still corresponding, but the y plus 1 corresponds to the 8. So 6 over 4 is going to equal 8 over y plus 1, okay? So we're going to set up that proportion on the next screen. Remember, when you cross multiply with the 6, you have to distribute the 6 to both the y and the 1. So put parentheses, okay? Subtract 6, divide by 6, you get 13/3 for y, okay? The actual math is not terrible. It's going to, maybe take you a little bit to figure out setting up the proportions, but I think you guys will be fine on this, okay? All right, so pause the video, give this a shot yourself. They tell me these two polygons are similar, and they want me to solve for A. Okay, so let's find some corresponding sides that I know. I know 5 corresponds with that 3, they're both on the bottom. And where is my A? Over on the right side. So then I gotta go right side over right side. So 5 over 3 is gonna equal 4 over 8. Cross multiply. 5a equals 12, and so I have to divide by 5. 12 divided by 5 is 2.4. So if you got 2.4, give yourself a pat on the back. Okay, very similar question. Pause the video, give this a shot. I'm going to set up a really similar proportion here, you guys. I've got 5 over 3 as corresponding sides that I know the values of. This time, B, though, is the top. So I have to go top over top. Okay, I'm going to cross multiply, so 2 times 3 is 6. Distribute the 5 to both of those. Okay, I'm going to add 30. Divide by 5, 36 divided by 5 is 7.2. So if that's what you got, good job. All right, perimeters of similar polygons. This will save you a lot of time if you pay attention to this theorem, you guys. If two polygons are similar, the ratio of their perimeters is the same as the ratio of their corresponding sides. So you don't have to actually calculate all the sides. If you know the perimeter of one, you can set up a proportion to find the other one, okay? So they tell me these are similar, and they want me to find the scale factor of one to the other, and then the perimeter of each polygon. Okay, so let's write down some things I know. If this is 4, that's 4. Okay, if that's 10.5 over here, this is 10.5. And this one's 7. So I know some of that information. What can I do to solve for some unknowns here? Okay, well, I know that 4 corresponds with 7. So I could do something like 4 over 7, and you'll see this in the next slide, is equal to, say, 6 over ST. Okay? Well, that would help me then find this unknown. Well, think about that for a second. If I can find ST, well, I know the perimeter of this. Sure. And then I can say 4 over 7 equals the perimeter of this one, which will be unknown, over what I get for the perimeter for the second one, and I can just solve the proportion. Okay? So, the first proportion is what we were talking about. 4 over 7 equals, and then we'll go DC over 10.5. So DC is going to be 6, which allows me to find the perimeter of one of those figures. Okay? So now I know it's 26. And I know that the ratio of the perimeters is going to be that 4 to 7 that we already calculated. And so I can say 4 over 7 equals perimeter over perimeter. Well, I know the perimeter of the first one. I just calculated it. So when I cross multiply and divide here, I've got the perimeter of the other one. It saves me a little time in that I don't have to use proportions to find the unknown sides and then add them all up to find the perimeter. I can just set up a proportion. Okay? So, give yourself a minute here, pause the video, give this a shot. Okay? You want to find the perimeter of each polygon. So, that's going to be 16. That's going to be 8 because of the congruence marks here. So let's add these up. 16 and 16 is 32, and 20 is 52, plus 6 is 60. So the perimeter of that figure is 60, okay? The ratio of the corresponding sides here, I've got a couple sides, 8 over 6, is then got to equal 60 over our perimeter, okay? And so 60 times 6 divided by 8, you should get 45 for that other perimeter. We knew the perimeter of the first one we had calculated. So this other one, if you take 360 divided by 8, you get 45. Okay? And there's your assignment. Good luck. Any questions, make sure you email me and ask. Thanks.